we will introduce the concept of the IP routing and then explain how the routing, how the router worked. Okay, and so first we will have the basic concept of the routed network. Okay, as we know, the global internet is a layer 3 IP network. But as we know, such a large network cannot be managed by one person or by one organization. So the network is constructed by different organizations. So each organization we called one autonomous system. Okay, such as your company have built a network, and another company build another network, and then the network of your company and the others company connected together. Okay, this is the internet network, but your company is managed by the administrator of your company, and then this is one autonomous system, and the network of the other company is another autonomous system. Okay, of course, the routing between different autonomous systems are also based on IP routing table. Okay, and then inside your company, it's a network that contains many lanes. That's many layer 2 networks. As we already know that one layer 2 network, okay, one layer 2 network is a broadcast domain. That means when one device is sending a broadcast in this lane, then all the other devices in this network will receive it. But the router divides the broadcast domain. Okay, the router did not forward the broadcast. Okay, so the network, if there's many devices, we must use the router to divide the broadcast domain to make the network scalable. Okay, so the switch is working on layer 2. The switch forwarding the frames, forwarding Ethernet frames based on the MAC address table, and then refer to the MAC destination MAC address in the Ethernet frame. And the router is worked on layer 3. Okay, the layer 3 means the router is working based on the IP routing table, not MAC address. Okay, MAC address table. The switch uses MAC address table, and the router uses the IP routing table. Okay, then the IP routing table is layer 3. So the packet sent by the PCs or the device then contain the destination IP and the source IP. Then destination IP using destination IP and the IP routing table to decide which is the next hop of this packet, and then sending out to the next hop. Of course, this router will repeat this process and then forwarding the packet to the destination. Okay, this is the concept of the routing. Okay, and the difference between the layer 2 network and the layer 3 network. The switch is a layer 2 device and the router is a layer 3 device. The switch based on MAC address table and the router based on the IP routing table. Okay, that's the 2 layers. Okay, and then the routing decision. Okay, of course the network may be connected as a mesh. Okay, partial mesh or full mesh. So from one source to the destination, there's different paths. Okay, then which path will choose to forwarding the packet? Okay, this is decided by the IP routing table. Okay, and the destination IP in the packet. Okay, destination IP, source IP, destination IP, and then finding in the IP routing table. Then decide which path will choose. Okay, and then we can see For example, what is the IP routing table look like? In the router, you can use the display IP routing table to see what is contained in the router's routing table. Then this is the content. Okay, we can see there's many columns. Okay, first is the destination network and the mask. Okay, and then the protocol, and then the preference, and then the cost, then flags, and the next hop, and the interface. Okay, here the destination and the mask uniquely identify each item. Okay, this is the one item in the routing table. This is the second item in the routing table. Maybe there are thousands of items in the IP routing table. Okay, so then the second is the protocol. Protocol means where, how does the router learn this destination network. Okay, direct means this network is direct connected to the router. Okay, and the router can learn the destination network and the mask from different protocols. There are three ways. First is the direct. Second, the network administrator can configure the routing table manually. That's a static route. Okay, using static route, you can configure it. And another, you can using the routing protocols, such as the loop, such as the OSPF, such as the ISIS. There's many different protocols. Then the router can learn the route items from protocols. Okay, and then the preference. The preference is binding to the protocol. Okay, the smaller one, the smaller value has the preference, has a higher preference. Okay, and when one network is learned from different protocols, then the protocol with the smaller preference will win. Okay, then the cost. The cost means what's the distance from the source, from here, from this router to the destination network. Okay, because this is directly connected, that means this network is directly connected to this router. So the cost is 0. If it's a far away network, then the distance must not be 0. Okay, and flags. The flags, there's explanations. R means relay. D means download to FIB, forwarding information base. D means this is effective. That's this route item is in use. The relay means you cannot find the output interface. Okay, in this routing item must be relayed. That means the next hop needed to refining in the routing table. Okay, and then next hop. This last two items, just to this destination network, which interface should put out this packet and what is the next hop for this packet. Okay, this is the columns, explanation of the columns of the routing tables. Okay, and then routing decisions. Okay, first in the routing table, the preference, we have explained the preference. The preference is binding to the protocols. Okay, in this topology, that means this network can propagate, can advertised by the OSPF, and also can advertised by the loop. Okay, that's two different protocols. Okay, so RTA can learn this route information from OSPF and from loop. Then there's a problem. Which route should RTA choose? That means RTA will put the packet destination for this network from this way or from this way. Then there's a mechanism we call preference. Different protocols have different preference. In the Huawei's device, the OSPF, the preference is 10, and the loop has the preference 100, and the smaller one wins. So OSPF will wins. That means RTA learned the destination network from two protocols, but only the OSPF route is effective. That means this route is active and then will be used. So in this network, destination network, learned from OSPF, preference is 10, and then the cost, of course, it's OSPF cost, and then next hop and the output interface. Okay, this is the preference, how preference is used to compare between different protocols. Okay, but then there's another decision metric. What's metric? That means if a same destination network, but now they are both OSPF protocols, then this network can send in this way, also can advertise this way. So RTA can learn the two route this network from two paths. One is from this path and another is from this path. Okay, so which path should I choose? Now in the previous slide we compare the preference, but they both OSPF, so the preference are both 10. So which one will I choose? Compare the metric. The metric just the distance from router A to the destination. If following this way, then the distance maybe it's 50. Okay, or this way is 50, and from this way the distance is 100, and then which one will I choose? The smaller one wins. So the RTA will choose this way, 30. The next hop is 30. Okay, this destination learned from OSPF, the cost 51 wins. Okay, then the next hop is the 30, not 20, because has the bigger metric, bigger cost. Okay, then the output interface is Ethernet 001. Okay, now we have compared two parameters to decide which path, which route is the best. One is preference, another is metric. The preference is compared between different protocols. Okay, the same destination network learned from different protocols, then compare the preference. Okay, and if the same destination network learned from the same protocol, then compare the metric. Okay, this is the two parameters. We compare which route is the best. Okay, and then there's another routing decision, the longest match. What's the meaning? Okay, first we should know in the routing table we can see such scenarios. This is two routing items, but you can see these two routing items have the same destination network, but the mask length is different. Okay, usually you may think that the network is the same. This is the same destination network, same route item. No, the route item is uniquely defined by these two pair, destination and the mask. Okay, if the mask is different, then this is two route items. So when there's something will be happen, for example, there's a packet going to the net destination. Of course, destination is not a network, it's an IP address 10.1.1.1. Okay, you can see 10.1.1.1 IP address is contained in this network, right? Because this network is 10.1.1 mask, 10.1.1.0 mask 24. So the network part is this. So the 10.1.1 contained in this network, but another, this 30 means contain 4 IP address. That's the 10.1.1.0.1 2, 3, okay? Of course, the 0 is the network address and the 3 is the broadcast address. So this is the two addresses that can be used in this network. And then this network can match two items, both items. But maybe in this scenario, the output interface and next hop is the same. Maybe these two may be different. Then there's a problem. What root item should be chosen as the next hop? Okay. The rule said longest match. What longest? The mask length should be longest. That means the biggest mask length, the 30, have a longest match. So this packet we are following this way. We are following this way. Okay. Of course, if the destination is 10, 1, 1, 10, 1, 1, for example, 9, then when you actually match, when you get to match these two items, you can see this network, this destination IP only can match the first network. The second cannot match, okay? This second only contains this full IP address. So the only matched item will be used, okay? This is the longest match. If matched more than one items in the routing table, then choose the longest mask length. Okay, this is a root decision. Okay, this root decision is different from the previous one. Previous one is to compare the root information and put it into the routing item. And this root decision is the root items have already exist in the routing table, and then how to use it when the packet needed to forwarding. Okay, that this is the how the router to forwarding the packet. When the packet is coming, and then the router will compare the destination IP. Of course, there's source IP and the destination IP. Okay, compare the destination IP to the routing table, and then in the routing table, the last two is the next hop and the output interface. Okay, then of course this is the Ethernet. Then we are sending the packet to this next hop. Of course, the layer 2 encapsulation is the same as in the LAN. Okay, need to up resolute the next hop's MAC address and then encapsulate and then sending packet to the next hop. In the router B, the same thing happened. Okay, the same thing happened. Router B finds the destination IP and then finding the routing table and then gets the next hop and then this packet sending to the next hop. Okay, repeat and repeat again, then this packet can reach the destination. Okay, this is the how router to forwarding the IP packet. Okay, this is different from the switch. Okay, switch based on MAC address. Okay, the layer 2 information. The router is based on IP address, the layer 3 information. Okay, and then we get to the end of this chapter. There are two questions. What is the order in which the routing decision is made? Okay, the routing decision made is a reference to the two. First, put the routing items into the IP routing table based on first one is the preference. Okay, if the route information is learned from different protocol, compare the preference. Okay, if the route information is learned from the same protocol, then compare the metric. Okay, then this route item is put into the routing table. But then when the packet is coming, and then the router, how to use the route items. Of course, if matched only one item in the routing table, then this packet we are sending out as the route item figured out. Okay, the route item says which interface to put out and which is the next hop. Then putting this packet, sending this packet to the next hop. And if there's more than one items matched, okay, then use which rule? the longest match. Okay, longest match. Use longest match. The root item with the longest mask length are used, and then forwarding the packet. Okay, there's another question. If this packet cannot match any one root items, that means none of the root items is matched by this packet, then what will happen? Yeah, this packet will be dropped. Okay, this is different from the switch. If on the switch, if the destination MAC address cannot find in the MAC address table, then this frame will be flooding out all the switch port. Okay, all the switch port. Okay, and then the second question: how does the preference represent? As we know, the preference just the preference of the different protocols. Okay, the smaller preference have the higher priority. Okay, the priority of the protocols, and of course the preference value have no standard. Each manufacturer assign a preference by itself. In the Huawei's device, the default preference, the direct connect is 0, and the OSPF is 10. The ISIS is 15. Okay, the static root is 16. Okay, the RIP is 100. Okay, and the OSPF has another value. If it's imported, the external root of the OSPF is 150. Okay, then the BGP root, that's the 255. Okay, this is the biggest value. Okay, but different manufacturers, the other company produce the router will use different values. Okay, different values. Okay, then